Welcome to Algebra with Miss Swartz. Today we're going to look at the quiz review you completed yesterday in class over sections 2.5 and 2.6. We talked about compound inequalities, which led us into absolute value inequalities. So we're just going to go over the problems that you had to do on that review, make sure you understand how to do them all, get any questions answered that you might have, and then take that quiz on Thursday. So here we go. It says write the sentence as an inequality. So remember we started with compound inequalities. We have two types of compound inequalities. We have and or. Okay, so that's what these are going to focus on. This says a number p is less than 6 and greater than 2. Okay, so what we can see is our smaller number, okay, our x is, or p in this case, is greater than 2 but less than 6. So this is what it would look like. Now, if you wrote this, that is okay too, but generally we like to kind of write in order of how it would come on a number line. Alright, so this one says the number r is no less than negative 1.5 and fewer than 9.5. Okay, so r is our number here. It says no less than, so it's going to be greater than or equal to negative 1.5. But it's fewer than, less than 9.5. Could it be equal to 9.5? Well, it says it's fewer than, so it can't be equal to. So we're going to leave it like this, as you can see. Now again, if you wrote it like this, that would be acceptable, but you do need the equal to over here because it says no less than. So it could be negative 1.5. Awesome. Moving on. Now it says write the sentence as an inequality and then graph the inequality. So this one says a number c is greater than negative 2 and less than 5. So c is greater than negative 2 but less than 5. So if we were to graph this, we could do okay. And we'll do 7 on here. An open circle at 2, but it's greater than 2. But then an open circle at 5, and it's less than 5. So we have that intersection there. So make sure you understand what graphs look like. Okay. So far these have all been and inequalities, and even this one becomes an and inequality here. But this one we have to solve and then graph. So for this one, technically we can do the same thing to both sides, so we don't have to separate it out. We're going to add 6 to all of the sides. So 18 plus 6 would be 24. And then this would be 40. And divide by 4. So 6 is less than x, which is less than 10. Now if you just separate it into 18 is less than 4x minus 6, and then 4x minus 6 is less than 34, and you kind of came to the same conclusion, that's fine as well. So we're going to graph this. This will also be an intersection. Open circle, shaded in between because it's greater than 6 but less than 10. Awesome. So hopefully those you had a good handle on. This next one was a little bit of a story. Oh, we have this one. We have an or finally on our problem. So we have two things we have to solve here. Remember what our ors should look like. They should go in opposite directions. So I'm going to subtract 5 from both sides. I get negative 16. Add 1 here. So I get negative 6. Divide by 2. C is greater than, or sorry, less than or equal to negative 8. Divide by 3. C is greater than or equal to negative 2. So we have a closed circle at negative 8, and it's less than negative 8, so it's going to be shaded to the left. And then we have a closed circle at negative 2, but it's greater than negative 2, so it's shaded to the right. We have our union there, going in opposite directions. Remember, you could always check these by picking a number either less than or greater than, or on our ands here, you could pick a number in between, like you could pick 8 here and see if that works. Alright, so number 6 was our story problem I was talking about earlier. It says, all it wants you to do is write a compound inequality that represents the possible temperatures. So it can range from negative 15 degrees to 105 degrees. So it wants you to say, okay, our temperature could be anywhere in between those two. So it's not going to be less than negative 15. So it could be greater than or equal to negative 15. But it should also be less than or equal to 105. So that's about as simple as it gets with your story problem. Just wanted you to write that compound inequality. Alright, so now we get to some absolute value inequality problems. We're always looking at our sign to kind of tell us what it would look like. So for number 7, okay, we have a greater than symbol. We know this is going to be an or inequality. And maybe that's something you want to write on your quiz right away tomorrow. Greater than is going to be or, less than will be and. We always break them off into two pieces. So we have x plus 2 is less than negative 3, and x plus 2 is greater than 3. So we'll subtract 2 from both sides. We have x is less than negative 5. Careful with your signs there. And subtract 2, x is greater than 1. So we'll graph it. Make sure your graphs are even intervals across. And then we have an open circle at 5 shaded to the left, and an open circle at 1 shaded to the right. Okay, number 8, if we look at it, we should be having an or inequality. If we go ahead and start working on the problem, we might run into the fact that this would end up being an and inequality when we go to graph it. So we got to know something is probably not right there, okay, when all is said and done. So I need to think about this a little bit. The graph would be a little funky if I start doing this. If I have an absolute value here, and I'm trying to figure out what numbers inside here can make this greater than or equal to negative 1, I have to think about that. Anything inside an absolute value is the distance from 0. So if something's the distance from 0, is it ever going to be less than negative 1? No, it's always going to be greater than negative 1. So I can just say all real numbers. And if I really wanted to make a number line, I can just shade in that entire number line going both directions because it's all real numbers. Any number that I plug in there is going to give me a positive number, which is going to be greater than negative 1, so our inequality is going to be true. So another way you can write it, because I know some of you do, is IMS. So as I talked about yesterday a little bit, if you see something that's greater than or equal to or greater than a negative number, okay, and it's simplified on the other side, meaning that the absolute value is by itself, you're going to have all real numbers as your answer. If you see less than or equal to a negative number, okay, and the absolute value is all by itself, you're going to have no solution because nothing inside of an absolute value is going to be less than a negative number. Awesome. Let's continue our last two here. So for number 9, we have another or. Didn't have a lot of and on this paper. So we're going to break it apart. N plus 5 is less than or equal to negative 1, and n plus 5 is greater than or equal to 1. Subtract 5 from both sides. We get negative 6 and negative 4. Closed circle at negative 6, shaded to the left, and closed circle at negative 4, shaded to the right. Okay, last problem on here. We spent a day going over some of this. We need to be able to get that absolute value alone first. So we're going to work furthest away from the variable or the absolute value. So I'm going to add 4, reverse order of operations. Here's where if you see a negative, don't panic quite yet. Make sure your absolute value is alone. Divide by 2 to get my absolute value by itself. So I would get absolute value of 2y minus 3 is greater than or equal to 5. So I'm okay here. This is going to be an OR as well. And I just need to solve for y on both sides. So I have 2y equals negative 2. Divide by 2. Y not equals. Less than or equal to negative 1. And then add 3 to both sides. 2y, I should be putting ORs in between these sentences. Divide by 2, y is greater than or equal to 4. So there's an OR, and that's kind of your complete sentence there. So if I graph this, so we have a closed circle at negative 1. It's less than negative 1, so it's going to the left. And a closed circle at 4, it's greater than that, so it's going to the right. And there we go. We have that OR. So we didn't have a ton of and inequalities, but those would be our unions where they're coming together. So make sure you would understand what that would look like. We had a lot of ands earlier in the worksheet, but we didn't work with a lot of them with the absolute value problems. If you have questions, be sure to ask. If not, just you can watch this video as many times as you need to make sure you understand and are ready for tomorrow. We will take the quiz tomorrow. Bring things to do just in case you get done early. Have a great day.